Please introduce yourself and briefly summarize your education and professional background.
My name is Apoorv Sinha, and I serve as the CEO and co-founder of Carbon Upcycling Technologies. I have a chemical engineering background and have been working in clean tech and sustainable materials for the last 10 years.
So what led you to co-found Carbon Upcycling, and what does the company hope to achieve?
Carbon Upcycling was founded with a vision of converting carbon emissions into a valuable resource. What we found about a decade ago was that there was a huge issue around a recognition of the major issue around carbon capture and what we need to be able to do to have a stable environment and climate. However, I think most of the efforts at the time were focused on carbon capture and storage underground. And so we were seeing that as kind of an economically kind of difficult argument to make for many different jurisdictions, even in developed countries. And so the value proposition behind carbon upcycling was to see if we can change the paradigm around CO2 and start looking at it more as a feedstock that can be used to make sustainable advanced materials, as opposed to a source of pollution that needs to be buried underground.
Can you describe the term upcycling and more specifically carbon upcycling? And how is it different from recycling and what are its advantages?
Yeah, a great starting point, frankly, is recycling, because we're all used to, drinking a bottle of water, dumping that into a garbage can, and then finding that again, make its way back through the supply chain. For plastics, for steel, recycling and using that material in its same life over and over again is a very common concept and needs to frankly grow a lot more in scale. What we mean by upcycling, Todd, is starting with a material that actually starts with a low value application. Like, for example, the heavy majority of the CO2 that we emit into the atmosphere comes from the combustion of very low value fuels. Some of it is coal, some of it is bunker fuel, some of it is petroleum coke. And these materials don't necessarily have a very good first life. And so the idea with upcycling is, can we take these emissions and make them into some kind of a valuable product, in our case, mostly solid building materials, and can we use them in a second life, essentially in another industrial application, in a more value-added version than was the case in its first life. And so with upcycling, we're really trying to get to a place where CO2 becomes more of a value-adding commodity or feedstock into these new chemical processes, as opposed to being, as I mentioned earlier, something that you have to store away at great societal and economic expense potentially.
So to better understand exactly what you and the company do, I noticed you have several partnerships with major cement producers. Now, how do you work with them and how is that different from what you do in-house? I guess I'm wondering, do you make your own cement or do you more help these cement producers make, better, more environmentally friendly cement with your technologies?
The core technology behind carbon upcycling is actually a very fundamental concept and a major pathway to reducing carbon emissions overall, which is mineralization. So the idea here is that you take carbon emissions from flue stacks or even from direct air capture, and you essentially are able to mineralize that into a rock. So this is very similar to the natural process of weathering. The core technology that carbon upcycling has developed is to be able to speed up the process kinetics, or basically the reaction times, so that what happens geologically over many decades and sometimes thousands of years can actually be done at an industrial scale and speed and be done in a few hours instead. And what we've really focused on with kind of our recent intellectual property development work and R&D work is to take that a step further and say that this mineralized carbon in the form of a supplementary cementitious material or an additive into blended cements can actually help store that carbon in a value-added product through the entirety of its kind of life away from the biosphere. And so to answer the second part of your question about kind of how we work with our cement partners, what we've appreciated over the last few years is that it is a large but extremely fragmented and localized industry. So, cement makes up 8% of the global industrial emissions, and it's over 4 billion tons of product that is being used by humans across the world. So it sounds like, very, very large numbers, and they are. However, most of the transactions of people using the cement involve local contractors, local builders, local engineering firms that do the specification and the regulatory verification work. And so with all of that local touch point, it is really important to find partners that are able to vertically integrate in a certain region. And what we're really focused on in our partnerships is to use the strengths that both of these sides bring to the table. So from our perspective, we bring the core IP, and we've done a lot of work in scaling up our technology. We've scaled it up over 10 million times in the last 6 years. So we want to be the engineering, research and development partners bringing the core IP to the table. And what we really rely on the cement companies to do is bring in the relationships, the partnerships, the understanding of the market, and working with the customers that they worked with for, in many cases, over 100 years, right? And getting them to feel comfortable with adopting this new technology and appreciating that, anytime you change something that you've done for a long period of time, it's painful, and it can sometimes lead to, unnecessary complications in delivering a project. But when you have a trusted partner that you've worked with for a period of time, and they're able to kind of articulate that this is really something we just kind of have to do to hit our climate targets, it becomes a lot more compelling. And definitely a lot of our partners have a lot more pull in being able to make that argument than us as a 40-odd person organization.
Can you cover a few more of the specifics about these partnerships? Like, what do you specifically do for them? Do you show them new ways to create their cement and help them along that process? I guess I'm kind of wondering a bit more about the specifics of these partnerships.
Yeah, absolutely. So the conventional way of making cement at a cement plant is through a calcination process. So essentially, you have a big oven, you take a feedstock like limestone, and you bake it at 14 to 1500 degrees C, like over 2000 degrees Fahrenheit, and you're baking this to chemically make the cement that you want to make. And so that thermal heat that you need is a big part of the emission profile of making cement, as is the fact that as you bake limestone, it releases CO2. And overall, by and large, you're emitting about 800 kilos of CO2 for every ton of cement that you make. What we're offering the cement players is essentially what they call a supplementary cementitious material, or an SCM. And this is an additive that can be blended into this limestone-based cement at fairly high dosages. So it can be as low as 20%, and it can be as high as 60%. And this blending allows them to reduce their reliance on this limestone heavy chemistry, which is inherently carbon intensive. And instead, that 60% that we could bring onto the table, as an example, would be sequestering carbon as opposed to emitting carbon for every ton that we generate. So really, our overall kind of value proposition to these groups is, these big cement companies have many cement plants that they own across the world. The three cement players that are investors in carbon upcycling own over 100 cement plants internationally across their asset base. And just to give you an idea, there are 2,600 cement plants overall in the world. And so with all of these, they have to work with locally sourced, cheap feedstocks that can be as easy and cost effective to activate into a cement as a limestone-based clinker. And that's really what we're offering them. We're not going to help them get to a net zero carbon solution in and of ourselves, but we can help them create a very cost-effective, compelling bolt-on solution that gets them more than halfway there potentially. And that's what we're really working with our partners to prove out at their plants. What we're very excited about at the moment is trying to engage with developers that are working in renewable industry projects, in affordable homes or home foundation buildings, as well as other civil work project contractors as well. So our thinking is that we've done a huge amount of volume in these low-grade applications, which still make up the bulk of cement and concrete use around the world. And so groups that are doing transportation-related work, sidewalk-related work, home foundations, slab-on-grade applications, and definitely renewable energy development projects. These are the type of players that we'd be very interested to connect with and talk about specific opportunities where we may be able to deploy our solution and help them reduce their CO2 emissions.
So our magazine is very supportive of making the industry more sustainable and doing lots of things to lower carbon footprints. So I've interviewed a few companies that are coming up with new technologies to make carbon less, or cement less bad for the environment, and things along those lines. Can you tell me a couple of things about what makes carbon upcycling different from some of these other companies doing similar work?
It is very gratifying to see the amount of innovation and the new innovators that are entering our space, because we've now been around for over 4.5 years, kind of entirely focused on cement and concrete. But just in that time, I think the number of startups in North America and in Europe has more than doubled. And so that's really great to see, because we need a lot of innovation. It's one of the big problems to solve in our times. And I would say ultimately our fundamental value proposition at Carbon Upcycling has been the same, which is, number one, we are very firm believers that no innovation can be successfully and scalably deployed unless it is cost effective. And so what we're really working with our cement partners to prove out, and we've already done with our commercial pilots in Western Canada, is we've shown that we have a cost-effective solution that does not require a green premium. The green premium can be great to help accelerate the adoption of the technology. There's no doubt that it can be a catalyst in kind of the rate of adoption, but it is by no means a necessity to be deployed in the field. And I think the second piece, which is kind of tied to that, is the fact that we can work with feedstocks as they are, not as we wish them to be. So what I mean by this is, we work with steel slags, we work with coal combustion ashes, we work with clay and mine tailings. In each of these cases, these materials are not very pure. We're not dealing with 98% industrial grade purity materials. We're dealing with slag pits at a steel plant that have been left behind over 100 years of a steel plant's life, or mine tailing deposits that have been collected over 40 years of a mining operation. And so to be able to use the materials without having to worry about, expensive pre-cleaning steps is really important with those feedstocks, and helps, as you can imagine, have a knock-on effect on being very cost competitive. And we do the same with our other feedstock, which is CO2. So many of these cement plants, it's a very low margin, high volume industry. The CO2 concentration at a cement plant can range anywhere from 8% to 15 to 20% by volume. A lot of technologies require pure CO2 to be effective. They need 99.9% pure CO2, and in some cases, 98% pure CO2. We can use that for 10, 15% CO2 as is, plumb that into our system, and use that to drive the carbonation processes or the CO2 related activation processes that we've patented and now are scaling. And so again, being able to use that without having to install expensive carbon capture is a huge factor that alleviates kind of the risks that we might provide to a company. And the last thing I'll mention here as well is, many of these companies that we're seeing emerge in the space are very exciting within the cement sphere because they can help you get to a net zero cement, right? They can come up with a limestone baking alternative to get you to a zero carbon cement with green electricity and things of that sort. In our case, because we're sequestering carbon into the cement that we produce or help our partners produce, we could actually help create a carbon negative cement. And that is really important because if, for those that might be interested, we have just launched a master plan as of 4 months ago, where we've essentially said that we want to learn how to scale our technology with our cement partners. And ultimately, when we become, the most cost effective and easy to scale mineralization technology, we want to start working with petrochemical groups. We want to work with plastics and fertilizer producers and other heavy industry to help reduce their carbon from their stacks and sequester that into rocks in an accelerated manner. And so from that perspective, I would say that's maybe the third strategic difference, is the fact that we're starting with cement, but by no means is that our end goal.
On these other products, I was going to bring that up. How is creating them different from cement? Is it very similar, or do you need to tailor it depending on what the starting materials are and what you're trying to create in the end?
So every cement plant will usually have a kiln, which is the oven where they bake the limestone, and then they have what they call a cement mill or a finishing mill, where they will usually add in additives or SCMs like ours. And conventionally, they've been using coal combustion ashes from coal power plants, which, as you can imagine, are shutting down at a record speed at the moment. Or they'll use blast furnace slag from blast furnaces that treat a lot of iron ore. As these blast furnaces are being replaced by electric arc furnaces, as coal power plants are shutting down and being replaced by renewables or natural gas, these staple cementitious materials that used to get blended in the cement mill are becoming less and less available. So to answer your question, that very same infrastructure that is already a part of how you build a cement plant or operate a cement plant would be exactly what we'd be tapping into to get our products into the blended cement at the end. So they don't have to make a fundamental shift at all. Essentially, really our core value proposition in that perspective, going back to a question from a few minutes ago, is the fact that we're giving them more options than they would have ever had. And we're doing that within the context of what their local supply chains are, so that we can help them be cost competitive.
Okay, and I agree that some of the more interesting alternatives that I've been seeing in the lower carbon have using locally sourced materials, in particular the inputs, and as well as the the additives that are often leftover properties nearby. Do you help the suppliers find those, or do they, since they're local, do they kind of lead the way into, hey, this is what we've got in our area? How does that relationship to find locally sourced materials work?
Yeah, it's a very good question. What I would say is that just around the time that carbon upcycling kind of pivoted from advanced nanomaterials to start focusing on bulk cementitious materials about 5 years ago, 4.5 years ago, um, that was around the same time that these cement companies began to become a lot more sophisticated in screening out local opportunities of pozzolans and not just pozzolans, but other feedstocks that they can use at their plants. One of the interesting things about the cement industry is the volume helps you nail down like potential prospects very quickly because if you find feedstocks that are available at a quantity of 10 to 20,000 tons a year, it's already too small to serve the needs of a normal cement plant. A normal cement plant will produce anywhere from 1 million to 2.5 3 million tons of cement a year. And so to make a 20, 30, 50% substitution, you need to make sure that the feedstock that you're looking at is available at least a few 100,000 ton scale. So whenever you draw that map and then you look at the radius that you can move these materials because they're expensive to move as bulk materials tend to be, it narrows down your options quite significantly. So I would say what we have done, especially in the last like 8 to 9 months, is we basically said there are three families of materials that would generally make sense in any given area. So that would be coal combustion products, it'd be steel slags, and it'd be clays. And essentially, what we try to do every time we identify an opportunity and investigate is try to find which of these three families of materials would make the most sense in that local area, and then we dig down with that. And usually, before too long, it becomes a pretty collaborative exercise because they've done their own homework. They may not have looked at some of those feedstocks that we were looking at because they didn't know they could become an SCM. So that's where we do a little bit of work educating them on some of the work we've done. And then they do the same with us in educating us about like the local supply chain, some of the relationships they may have with some of these players and things of that sort.
Okay, so in addition to trying to work into different materials besides cement, what are some other ways you're looking to improve in the near future? Some ways to improve what you're doing or to appeal to even a wider audience?
I would say the overall mineralization angle has been an extremely exciting and ambitious kind of scope of work that we've taken on since last July. So we closed our Series A fundraise in July last year, and one of the things we started ideating on immediately was, a lot of our focus has for the last 3.5, 4 years been on industrial byproducts. So, for example, for every ton of steel that you make with an electric arc process, as an example, you'll be producing about 150 kilos of slag. Now, if that slag is a great SCM, that's great, but no one's ever going to make steel to make slag. They're always trying to make steel first, and you have a byproduct. And essentially, what that means is that you have an upper limit of how much of that feedstock can potentially be available. What we've done over the last year is really focus on natural materials that have an affinity to take on CO2 and become a real sink for carbon in the atmosphere. And that work has really accelerated in the last 10 months. We worked with materials like olivine, with basalt, with peridotite, a whole bunch of these volcanic rocks in many cases, which have a propensity to capture CO2 and store it for hundreds of years in a very permanent way. And so where this gets exciting to us and has more implications outside of just cement is, if you're a petrochemical refinery in Greece or in Japan or in Turkey, like in areas where, because of seismic activity or maybe even public policy, you have no real way of storing that CO2 underground. Most of Southern Europe has this challenge. And if you don't have that option and you cannot store that carbon underground, the only other option you've got is scalable ex situ mineralization, which is taking powdered rocks on the surface, storing the carbon into that, because even if policy doesn't allow you to build a pipeline or an earthquake doesn't allow you to have the stability that you need, this rock can store that CO2 and it's not going to get released if there's an earthquake, right? And so that has been our real big focus over the last 6 to 9 months. And I think with some of the developments that we will be in a position to announce early in 25, we'll be able to start kind of bringing a syndicate that is much broader than cement, hopefully, into the camp and start kind of commercializing and scaling our technology as a pure carbon capture and storage complementary solution to what's happening with conventional CCS.
Okay, so most of our audience is the civil and structural engineers who design and specify the infrastructure in the world. What advice might you give them that what they need to learn or know about low carbon cement so they can get more sustainable materials into their own designs?
One of the the most challenging things that we've seen with regards to changing specifications is um, whether the local specifiers and the civil engineers are aware of some of the latest information that's out there. I mean, ASTM just in the next few months is going to have a standard that's going to go out that's going to allow many more naturally derived cementitious materials to be used in blended cements and concrete mix designs. However, that doesn't necessarily mean that every engineer or architect or specifiers at a contractor are going to feel comfortable with the use of some of these materials. And I would just say that it is very, very important to understand the importance of talking to companies, not just like us, but some of the customers that we work with, to understand that there are new types of materials that are coming into the fray and they're being commercially deployed. We've deployed over 3,000 tons of material in Canada over the last year and a half, or sorry, 2.5 years. And this really has given us a lot of case studies where we've done this in sidewalks, we've done testing with high performance concrete, and definitely with home foundations and things of that sort as well. And so, I would just urge them to start talking to their vendors and really listening to what type of new solutions that are out there, because this is, as you mentioned earlier, a rapidly evolving space and with a lot of new exciting things coming online.
Okay, that's great. And then as an expert in the decarbonization industry, do you have any other general advice to engineers so they can help, like I said, improve decarbonize infrastructure in general, something they could do maybe in the very near short-term future?
Ultimately, I think we have to be comfortable with taking some calculated risks with a few of these foundations. I mean, obviously, for any type of construction project, you've got safety margins, you've got, certain things that you might have play with and certain things where you do not want to tolerate any kind of new technology risk. I would just say that what we found in a multitude of projects is that there's almost always a concrete element, like a project that has a concrete part to it. There's almost always a segment or a portion of that which is capable of testing out new materials with little to no risk. It's not always the case, but I would say it's almost always the case. And so I would just urge them to, be curious about some of those solutions, talk to companies like us and others that are really beginning to deploy volumes into the field, and really talk to contractors and the builders, right? Like a lot of these cement and concrete companies have developed a lot of in-house expertise in quality control and really just kind of standing by the value and the quality of the products that they're putting out in the field. And so I would say the more they can get up to speed on some of that work, I think the better position they'll be in to take some of these calculated risks to help us meaningfully make some progress in adopting these new technologies.